A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
You ever look at a folder on your desktop and realize you were staring at a comforting lie? I was thinking about this while organizing some project files yesterday. We see these little yellow icons. We nest them inside each other, and we imagine this tidy physical hierarchy like a filing cabinet in a dream. But as soon as you step into the world of large-scale cloud infrastructure, that dream evaporates. Today's prompt from Daniel is about how object storage, specifically something like Amazon S3, is fundamentally different from the local file systems we have been using since the 80s.
It is a perfect time to talk about this because Amazon S3 actually just celebrated its 20th anniversary on March 14th, 2026. I am Herman Poppleberry, and I have been digging into the latest State of the Union reports from AWS. When S3 launched back in 2006, it was basically 15 racks of hardware. Now, as of this month, they are reporting over 500 trillion objects across their global infrastructure, handling more than 200 million requests every single second.
500 trillion. That is a number so large it stops being a statistic and starts being a geological feature of the internet. But to Daniel's point, when a developer interacts with those 500 trillion objects, they are not using the same logic they use to save a Word document to their hard drive. You mentioned the anniversary, but there was a massive technical shift this month too, right? Something about the naming war finally ending.
You are thinking of the Account Regional Namespaces update that dropped on March 12th. For 20 years, if you wanted to name a bucket My Data, and someone in Dublin or Tokyo had already taken that name, you were out of luck. Bucket names had to be globally unique across every single AWS customer. It was a massive pain point for automation and security. But as of 2 weeks ago, AWS finally implemented a system where bucket names only need to be unique within your specific account and region. It sounds like a small quality of life fix, but architecturally, it represents a huge shift in how they handle the global index.
It only took them 2 decades to let me name my own buckets whatever I want. Progress moves at a sloth's pace sometimes. But let's get into the why here. If I am on my laptop, I'm using NTFS or APFS, or maybe ext4 if I am feeling spicy. Those are all POSIX compliant, which we should probably define, because it is the root of the friction people feel when they move to the cloud.
POSIX, spelled P-O-S-I-X and usually pronounced P-A-H-Zix, is essentially a set of standards that define how an operating system should behave. For a file system, being PA-H-Zix compliant means you can do very specific things. You can open a file, you can seek to the middle of it, you can change a single byte, and you can save it without touching the rest of the file. It is designed for low latency, random access operations. Your local NVMe drive might have a latency of maybe 10 to 100 microseconds. It is incredibly fast, but it is also very fragile and limited to that one physical machine.
Right. So if I have a giant database file on my hard drive and I want to update one user's phone number, the file system just goes to that specific spot on the disk, flips the bits, and calls it a day. But if I try to do that with an object in S3, the whole thing falls apart.
It does because object storage is fundamentally immutable. When you put an object into S3, you are not writing to a sector on a disk in the traditional sense. You are interacting with a RESTful API over HTTP. If you have a 5 GB video file stored as an object and you want to change 1 second of footage in the middle, you cannot just edit it. You have to re-upload the entire 5 GB object. The system treats every file as a single discrete unit of data. This is why we call it object storage rather than a file system. You are storing blobs of data, and once they are there, they are set in stone until you replace them entirely.
That sounds incredibly inefficient if you are thinking like a desktop user. But I assume the trade-off is what allows for that massive scale you mentioned. If I am a developer and I am used to the hierarchical tree of folders, how does S3 actually organize those 500 trillion things?
That is the core of it. Local file systems rely on something called an EYE node table, or inode table. Think of an EYE node as a record that tells the computer where the actual data blocks for a file are located on the physical platter or flash chips. It is a map. As you add more files, that table grows and searching it becomes a bottleneck. You cannot have a single EYE node table that spans 100,000 servers. Object storage replaces that hierarchy with a flat namespace. There are no folders. There are only keys.
I love this part because it blows people's minds. When I see a path like bucket name /images /2026 /photo.jpg, my brain sees 3 layers of folders. But you were saying that is just a string.
It is just a name. The / character is not a directory separator in S3, it is just another character in the key, which is the unique identifier for that object. When you use a tool that shows you a folder view of S3, it is just doing a string search for all keys that start with that specific prefix. It is a database query, not a directory traversal. In a local file system, if you delete a folder, the OS just updates the EYE node table for that directory. In S3, if you want to delete a folder, you actually have to send a delete request for every single individual object that has that prefix in its name.
This is why cloud migration can be such a headache. People try to mount S3 like a network drive, which we talked about way back in episode 770 when we looked at rawclone. If your application thinks it is talking to a local drive, it is going to try to do those random access PAH-ZIX operations, and S3 is going to just stare at it blankly.
ArcClone tries to do the heavy lifting of pretending S3 is a local drive, but as soon as you try to run an application that expects PAH-ZIX behavior, like a database that wants to do random writes, the latency kills you. You are moving from microsecond latency on a local bus to 100 or 200 milliseconds of latency over the internet, plus the overhead of the HTTP handshake for every single operation. If you try to save a tiny text file, you are doing a full TCP connection, a TLS handshake, and an HTTP PUT request. On a local disk, that is a few CPU cycles. In the cloud, that is a whole journey across the country.
And that brings us to the durability side of things. Local file systems are prone to bit rot and physical failure. If your drive head crashes, that data is gone. S3 is designed for what they call 11 nines of durability. That is 99.9 followed by 8 more nines. To achieve that, when you upload an object, AWS typically replicates it across at least 3 different physical availability zones, which are essentially separate data center clusters miles apart. If a literal meteor hits one data center, your cat photo is still safe in the other 2.
And that replication is the reason for the latency. You are waiting for that data to be mirrored across a geographic region before the API returns a success message. But I saw that AWS is trying to fix this with the S3 Express One Zone class. That feels like they are admitting that sometimes people just want the speed of a local drive even in the cloud.
S3 Express One Zone is a fascinating pivot. They launched it to handle the massive I/O demands of AI training. In that model, they sacrificed the geographic redundancy. It stays in one availability zone to get single-digit millisecond latency. It is basically the closest they've come to making object storage behave like a high-performance local block device, but it is still accessed via the same API logic. It is for those chatty applications that need to read and write millions of times, but do not necessarily need to survive a regional disaster.
Let's talk about the metadata, because that is the other big differentiator Daniel mentioned. On my Mac, if I want to tag a file, I am limited to what the OS allows, maybe a color label or a few keywords, but with S3, you can attach rich metadata.
This is where object storage starts to look more like a database than a file system. In a local system, metadata is usually just the file size, the creation date, and the permissions. In S3, you can attach custom key value pairs to the object itself. You can tag an object with project, alpha, department, finance, or retention policy, 7 years. Because these tags are part of the object, you can build entire automation pipelines around them.
You could have a policy that says any object tagged with finance gets moved to cheaper archive storage after 30 days. You cannot do that easily with a traditional folder structure without writing complex scripts that crawl the EYE node table. In S3, the storage itself is intelligent in a way, it knows what it is holding. This decoupling of the data from its location is what makes the cloud so powerful. You do not care which server the file is on, you just care about its key and its tags.
It makes the storage searchable in a way that is decoupled from where the file is located. But there is a catch here, and it is something that has become a major controversy this year. We are seeing this API tax debate heating up. Herman, you've been tracking the costs on this, right?
The API tax is the big story of 2026. For years, the complaint about cloud storage was egress fees, the cost of getting your data out. Cloudflare really pushed the market there with their R2 service and the zero egress model, which eventually forced Amazon and Google to drop most egress fees for customers leaving their platforms back in 2024. But now that moving the data is cheaper, the providers are leaning harder into request fees.
Right, because if you are running an AI workload that is doing millions of list or put operations a second to fetch vector data, those fractions of a cent per request add up faster than the actual cost of storing the gigabytes. I was reading a report that for some high-frequency workloads, the API request fees are now 60 or 70% of the total bill. If you have a million tiny files, you might pay $10 to store them, but $1,000 just to check if they are still there.
It has completely changed how we have to architect systems. In a local file system, doing a list files operation is practically free. In S3, every time you ask the system, tell me what is in this bucket, you are paying for that API call. This is why we are seeing that repatriation trend Daniel referenced. The latest industry reports from early March 2026 show that 45% of mid-sized enterprises have moved at least one major workload back to on-prem block storage.
45%. That is a massive reversal of the cloud-first mantra we have heard for the last decade. Is that purely a cost play, or is it about performance predictability?
It is both. When you are on-prem using a system like MinEYEO, which is an open source, S3 compatible suite, you get the benefit of the S3 API for your developers, but you are running it on your own NVMe hardware. You get the predictability of knowing exactly what your latency will be, and you are not getting hit with a bill for every GET request. Mid-sized companies are realizing that for certain steady-state workloads, the infinite scale of the cloud is an expensive insurance policy they do not actually need. If your data grows at a predictable rate, why pay the API tax to a giant provider?
It is funny because it comes back to that plumbing we talked about in episode 728. If you understand the underlying file system, whether it is ZFS or a flat object store, you can make better decisions about where that data should actually live. But I want to go deeper on the AI side of this. Daniel mentioned S3 vectors going into general availability this month. That feels like a direct response to this API tax and performance issue.
S3 vectors is a huge deal. Traditionally, if you wanted to do a vector similarity search for an AI model, you had to pull your data out of S3 and put it into a specialized vector database like Pinecone or Milvus. That meant paying for egress, or at least paying for the compute to move it. With S3 vectors, you can now perform those similarity searches directly on the objects where they sit. AWS is essentially moving the compute closer to the storage to minimize the data movement.
It is turning S3 from a cloud hard drive into a compute-adjacent platform. It is like the storage itself is becoming a database engine. But does it break the simplicity that made S3 popular in the first place? I mean, the S in S3 stands for simple. Is it still simple when it is doing vector math and regional naming and single-zone low-latency tiers?
It is definitely getting more complex, but the core simple part is still the API. If you know how to write a PUT or a GET request, you can use S3. That is the genius of it. They have kept the interface the same while completely swapping out the engine and adding a turbocharger. The real challenge for us as users is unlearning the habits of the local file system. We have to stop thinking about folders and start thinking about data management.
I think that is the biggest takeaway for the developers listening. If you treat S3 like a nested folder on your laptop, you are going to have a bad time. You're going to have high latency, high costs, and a lot of frustration. But if you embrace the key value, nature of it, if you use the metadata to its full potential and architect for immutability, you can build things that are literally impossible on a local machine.
One thing I find wild is the durability math. We say 11 nines, but if you translate that into real-world terms, it means if you store 10 million objects in S3, you can expect to lose exactly one of them every 10,000 years. Compare that to a local hard drive where the annualized failure rate is often between 1 and 4%. It is a completely different category of reliability. Your local drive is a temporary scratch pad. S3 is a digital monument.
Unless you accidentally delete the bucket yourself. No amount of nines can protect you from a tired developer with admin privileges and a bad script. I have seen more data lost to a delete recursive command than to hardware failure.
Which is why versioning and object lock are so important, but that is a whole other rabbit hole. The point is, the cloud hard drive is a metaphor that has outlived its usefulness. We are moving into an era where storage is a distributed database that happens to hold files. The March 2026 updates prove that AWS is leaning into this. They are making it easier to name things, easier to search things with vectors, and faster to access things with Express OneZone.
So, for the developers listening, what is the move? If you are starting a new project in 2026, do you go all in on the new S3 vector features? Or do you look at that 45% repatriation stat and think about staying closer to the metal?
I think the move is to audit your request patterns. This is the most important takeaway. If your application is chatty, meaning it makes thousands of small requests, you either need to move to S3 Express OneZone or look at an on-prem solution like MinEYEO. If you are building for write once, read many scale, then the traditional S3 model is still the gold standard. And for heaven's sake, start using the custom metadata. Stop trying to bake all your information into the file name string. Use the tags. That is what they are there for.
It is about using the right tool for the job. A sloth does not try to run a marathon, and you should not try to run a high-frequency trading database on standard S3. I think we have covered the architectural shift Daniel was looking for. The folder is a lie, the slash is just a character, and the API tax is the new reality. It is a world of flat namespaces and RESTful calls now.
It really is, and I am curious to see where we are in another 20 years. Will the concept of a local file system even exist, or will our operating systems just be thin clients for a global object store? We are already seeing the lines blur with things like S3 vectors.
If it means I never have to see a distful error message again, I am all for it. But I suspect we will always want that microsecond latency for our local tasks. There is something satisfying about a file that actually lives right where you put it, even if it is just a comforting lie.
That is the donkey in you, Corn. You like the sturdy physical reality of the local disk. You want to feel the platter spinning.
Guilty as charged. Well, I think that is a wrap on the architecture of the cloud. Thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes.
And a big thanks to Modal for providing the GPU credits that power the research and generation pipelines for this show. They make it possible for us to dive this deep every week into the technical weeds.
This has been My Weird Prompts. If you are enjoying these deep dives into the plumbing of the internet, do us a favor and leave a review on your favorite podcast app. It really does help other people find the show and helps us keep the lights on.
You can also find our full archive and all the ways to subscribe at myweirdprompts.com. We have over 1,400 episodes in there now, covering everything from the history of ZFS to the future of quantum networking.
Search for us on Telegram too if you want to get notified the second a new episode drops. We will be back next time with whatever weirdness Daniel or the rest of you send our way.
See you then.
Later.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the close from sloth